Alright, so here's our third video, and we just dealt with multiplying radicals, and now we're going to have to deal with what happens when you divide radicals and when you have fractions inside the radical. So there's a whole slew of things we have to sort of worry about here. So let's start by at least talking about what happens when you multiply two fractions. So we're going to multiply 2/3 by 2/3. Remember, the way you multiply two fractions is you multiply the tops and you multiply the bottoms. And so on top you get 4, and on bottom you get 9. Now, we just multiplied the same fraction twice, so one way to think about that is that's 2/3 squared. And so if we ask the reverse question, what is the square root of 4/9? The answer is 2/3, because 2/3 squared is what's inside. Right, remember, that's one way we can answer the square root question. If we know something so that when you square it you get the radicand, right, what's underneath, then that's the answer to the square root. Now, let's look at what happens if we have, let's take the square root of 16/25 and then ask, what if I took the square root of the top and the square root of the bottom separately? Well, the square root of 16 is 4, and the square root of 25 is 5. And so if I just wanted to, if the only thing I cared about was evaluating the square root of 16 or the square root of 25, the answer would be 4/5. Now, let's multiply 4/5 times 4/5. What I get is 4 times 4 over 5 times 5, which is 16/25. And so the answer to our top question, the square root of 16/25, is actually 4/5, because 4/5 squared is the radicand. Right? So the rule is that the square root of a fraction is just the fraction of the square roots. And then we have to add as long as A and B are positive. Remember, if A or B are negative, then one of these won't be defined, or at least one of them. And so you can't break it if they're not. So let's practice the square root of 27/16. Well, that's the square root of 27 over the square root of 16. Now, we know 16 is a perfect square, so the bottom's going to become 4, but 27 isn't. So let's break 27 into 3 and 9. Now, from our last lesson, since 9 is a perfect square, we don't have to worry about it anymore. 3 is a prime number, and so it can't be broken down any further. So the top we can write as the square root of 9 times the square root of 3. Right? 27 changes into that. And then radical 9 becomes 3. And so we get this lovely little fraction, 3 radical 3 over 4. Let's try another. So here we have 63 over 8. Now, 63 is not a perfect square, and 8 is not a perfect square, so we're going to have to do some work. 63 is 9 times 7. 8 is 4 times 2, and remember, you don't have to factor the perfect squares once you've pulled them out, and if the remaining number is prime, that's what will be left. So this is radical 9, radical 7, over radical 4, radical 2, which is 3 radical 7 over 2 radical 2. Now, I haven't told you yet, but we don't like radicals in the denominator. And so we're going to have to come up with a way to deal with that. And the way to deal with that is by looking at what happens when you multiply a radical by itself. So look at radical 3 times radical 3. Well, that's radical 3 times 3, which is radical 9, which is 3. Radical 5 times radical 5 is radical 5 times 5, which is radical 25, which is 5. So you should notice that if we take a radical and multiply it by itself, we can get out what's underneath. We can extract the radicand. We took a radical, multiplied it by itself, and we extracted the radicand. So the rule is radical A times radical A is just A. It's always A. So if we look back here, I'm going to take this, and I'm going to copy it, and I'm going to bring it over. So we have 3 radical 7 over 2 radical 2. The denominator, we don't like the fact that there's a radical 2 there, right? That makes us sad. But if I multiply by a radical 2, both of these are going to combine and give me a 2. Now what's really, really important is you're not allowed to just multiply by anything you want. You can only multiply by 1, so we need to also put a radical 2 up top. Now, the 2 gets carried over, and then these become 2 as well. The 3 comes over, and we have radical 7, radical 2. Now, we have a 3 up top, a 4 down below, and radical 7, radical 2 can be combined into one radical. Remember, when you multiply two radicals, you just multiply the radicands, and so we get 14. And this is the acceptable answer. So if I ask you to simplify, let's do 3 over radical 5. And let's also simplify while we're here. 6 over radical 2. So both of these have radicals in the denominator, and we don't like that. And so what we're going to do is we're going to multiply by the radical on top and bottom. And remember, two radicals of the same radicand in a row just give us the radicand. So we get 5 down below, and up top we get 3 radical 5. Here we multiply by radical 2 over radical 2. And then these multiply to give me a 2. And I get a 6 radical 2. Now here we're not done. 6 and 2 have a common factor. 2 goes into 6, leaving me with 3. So the end answer is just 3 radical 2. So sometimes we're going to, just like we used the multiplication rule in both directions, right? Sometimes we had the square root of two things being multiplied underneath and wrote it like this. And sometimes we had this and wrote it like that, right? These rules go both ways. This rule clean that up. this rule goes both ways too. Sometimes you're going to have a fraction of two radicals, and you're going to want to instead write it as one radical. And so let's look at when that might happen. Let's simplify the square root of 2 over the square root of 18. There's a bunch of ways we can do this, but one of the nicer ways is to note, if you look at the two radicals and you notice that they have something in common and they might cancel, if you make it just one fraction again, like that, now you can cancel it, right? 2 over 18, that becomes a 1 and that becomes a 9, and so what we get is the square root of 1/9, which we can then break back up, giving us a third. The other way we could have handled that was multiply top and bottom by radical 18. The top becomes 36 because 2 times 18 is 36. The bottom becomes 18. The top becomes 6. The bottom is still 18. And then 6, right, goes into 18 3 times, and so we're left with a third. This way, to me, seemed like a lot less work, and this way seemed like a lot more. And so sometimes if you have a fraction with radicals, you're going to want to combine them. And so let's do just a couple more examples. So when we get rid of radicals in the bottom, we call it rationalizing. So I want you to rationalize, here's a couple of examples, the square root of x squared over 20. We can write this, you remember, as the square root of x squared over the square root of 20, which is x over the square root of 20. And now let's multiply top and bottom by the square root of 20. And so we get x radical 20 over 20. Now, you're not done until you've made sure that you can't pull out anything from the radical. 20 is 4 times 5. And so radical 20 is radical 4 times radical 5, and radical 4 is 2. And so the top becomes x times 2 radical 5 over 20. Now, you should notice that 2 and 20 have a common factor of 2. 2 goes into 2 canceling, leaving me with radical 5 into x. 2 goes into 20 10 times, leaving me with a 10 down below. And so there is my answer. One more example. Let's do radical 5x over radical 2y. So we need to multiply top and bottom by the denominator. We have one radical followed by another, and so we just get what's underneath. And on top, we get 5x times 2y. Right? Remember, when you multiply two radicals, you can just multiply what's underneath. Now, 5 times 2 is 10, x, y, over 2y. One last, square root of y to the 5th over the square root of xy squared. Now, here, you want to break y to the 5th into the biggest perfect square. Y to the 5th is y to the 4th times y. Y to the 4th is the highest even power of y before we hit 5. Radical x, radical y squared, we get radical y to the fourth times radical y over radical x. Now, radical y squared, since y squared is a perfect square, the square root of it is just y. Likewise, y to the fourth is a perfect square, and so the square root of that is y squared. So I'm going to go ahead and take this and drop it here. This is the most recent thing that we ended up with. And so we need to finish this. We have y squared radical y over y radical x. Now we have a y squared up top and a y down below, and so one of the y's is left up top and the y down below is gone. So we're left with y radical y over radical x. We need to multiply by radical x over radical x, and then the bottom becomes x, the top becomes y radical x, which becomes y radical yx over x. And finally we have our answer. So that's really it. Go ahead, do the homework, and I'll see you in class.